podcasts you love.
From people you trust.
This is TWiT.
This is TWiT News special number 383, a very exciting day for July 12th, 2022. Hello, everybody. Leo Laporte here, joining me, Rod Pyle, host of This Week in Space, editor-in-chief of the Ad Astra magazine, author of many space books, and a little boy who was so excited he had to get up at 4 a.m. today because we are going to see images from the James Webb Telescope. Good morning, Mr. Pyle.
Good morning. And how are you this good morning? It's early.
It's early. It's 10:30 in the East Coast. So, I guess NASA must be on East Coast time. But this is really exciting. Now, we were a little worried because President Biden yesterday jumped the gun and released one image. But I have to tell you, and by the way, John, go to the press conference as soon as it begins. It should begin in a couple of minutes. I have to tell you, even that first image was very, very exciting. And Rod, you had some excitement in particular because you have the image of the same region of the sky with the Hubble. Now, first of all, what are we looking at? What is the region of the sky?
Well, it's got the very unromantic name of SMACS 0723.
SMACS 0723.
SMACS 0723. And as NASA put it yesterday when they were attending the press conference with Biden and Harris, they pointed out that the region we're looking at there is the equivalent of holding a grain of sand at arm's length in terms of how much of the sky you're seeing. So that's just one little tiny bit. Everything you're seeing there is a galaxy.
Wow.
So the bright objects in the foreground.
The left is the Hubble and the right is the Webb. You could see that there are galaxies on the Webb, big time.
Yeah.
I mean, they look like spiral galaxies, like what we think a galaxy looks like.
And in that image on the right, so you see the bright objects in the foreground, which are presumably SMACS 0723, which is a big high mass object. And so it's dense enough and has sufficient gravity that it's bending light around it. So they're using a technique here called gravitational lensing, which we've talked about in the past. So those smeary worm-like objects that you see off to the right and the left of the bright center point of light are gravitationally magnified objects much more distant than the foreground. So in the foreground, you're looking at something that's about 4.6 billion years ago. According to Bill Nelson yesterday, there are other objects in there that are more than 13 billion years old. And remember, the universe is only about 13.7 billion years old. Wow. So those wormy objects are being magnified from way, way in the background, which when it finally got through my skull, what I was looking at, I thought, oh my God, this is, we're looking back at almost the beginning of time. This is just one of the first images. And obviously, they went for the goalpost image here to show how amazing this instrument is. And we'll be seeing a bunch more stuff, more specific today. Shall I give you a little preview?
Well, in about 30 seconds, we're going to go. Where are we going to go? Is this DC? Where are we going to?
This is at Goddard Space Flight Center in Maryland. And they're overseeing the telescope project.
And what are they? How do you expect? It's going to start in a few seconds, so I guess there's no point.
So in the last half hour, they had a bunch of senators and Congress people on. And
we skipped that part, notice.
Yeah, I mean, they were thanking their district and their tenacity and their perseverance and all that. And here we go.
All right. This is very exciting.
Skywatchers, this is it. This is the day we get the first science images back from the James Webb Space Telescope. And you've got a front row seat to the cosmos. I'm Michelle Thaler, your host for what can only be described as a celebration for everyone on Earth. So think about this. Light from the earliest days of the universe has been traveling to us for billions of years. Just over the last few weeks, we've captured some of that light with a telescope that sees the universe in an entirely new way. And today we share the very first results. So longtime space fans are going to know who this is. This is Dr. John Mather. He's the senior project scientist for the Webb Telescope and a Nobel Prize winner. And John, I couldn't be happier to be here with you today.
Thank you. It's a thrill to be here for this very special day.
How are you feeling?
I am thrilled and I'm relieved because, when you start something this big, there's always a possibility it might not work. It did work. We are so proud.
And you've been on this project for a very long time, right?
Yeah, started in 1995. We had just finished measuring the Big Bang. We measured it with the Cosmic Background Explorer satellite that we built right here at Goddard. And we measured the spectrum. We measured there are hot and cold spots in the Big Bang. So we said, now we know it all, how it all got started. But then what happened after that? So then I got a call from NASA headquarters. Would I like to work on this new telescope that's going to help answer those questions? What happened after the Big Bang? How did the galaxies grow? How did the first black holes grow? What happened all the way from there to here? So this is our time machine, and I just wanted to be part of it. I am so thrilled that we got a chance to do it.
One of the things that I remember you saying, and this is kind of amazing, that after you win the Nobel Prize, you thought that this mission was the most important thing to work on.
Absolutely. It's the next question. After you know how it started, what happened then? And, suddenly we now have the technology to do it. We didn't have 50 years ago. Didn't have the technology 25 years ago, even when we started this. We had to invent things along the way, so we did that, and here it is.
Well, thank you. We'll be back to you in just a moment. So at the moment, we're going to talk about the way that Webb is a completely new way to explore the universe. So today, the mission releases its first science images and gives wings to the dreams of so many people who worked so hard for so long to make this possible. For everyone on Earth, this is your telescope.
So there are multiple goals, obviously, whenever you put an instrument like this different scientists. How do they get access to images from the Webb? How do they decide what the Webb looks like?
Well, so they set up a peer review panel in Maryland, I believe, to look at all the proposals from all over the world. So this is really a gift to the whole planet. This isn't just a U.S. mission, even though it's a NASA mission. There's proposals that would come in from everywhere.
Too, right? The European Space Agency as well.
Yeah, and a bunch of other groups. But, the thing that's so cool about it is they said, look, anybody can submit, including grad students. They've anonymized the proposals so they won't be biased by big names or Nobel Prize winners. If it's a good proposal, it gets time. So you and I can submit one if we want. And their primary targets in the first 6 months, as were explained to us by Mark Clampin, who's the chief of this division at NASA Goddard in the This Week on Space podcast, is to obviously look at the oldest and furthest and most distant things they can see. The reason they want to do that, besides just making that milestone, is to see objects in the earliest stages of their formation, so galaxies, stars, potentially exoplanets, really in their youngest phases, because we've never seen that before. So this telescope, as we've talked about, can look back to within about 1 to 200 million years of the Big Bang. So we're looking at the children of the universe, if you will, and seeing them at their very, very earliest stages. So that's the main thing. But closer to home, they're going to be looking at Jupiter, because they're trying to study and understand the cloud structures there and learn more about things like the Great Red Spot. And they're going to be looking at comets. And, of course, they're going to be looking at exoplanets. And it's worth bearing in mind when this telescope was first being designed.
Hold on a second. I want to hear a little bit about... They're really having trouble with their stream, aren't they?
In the background there. That's the way we do. And so naturally, we're also going to be visiting the nerve center of this mission, the Space Telescope Science Institute on the campus of Johns Hopkins.
We should talk whenever it's propaganda. I'm sorry, PR for NASA. But when there's actual science, I would like to hear what they say.
Of course.
So we'll be back with our international partners shortly, where they'll each reveal one of the new images.
Just figure out how to get them
be joined by
on the
millions of science fans from around the world.
They need the tech guy.
Just for this event.
Well,
so here we are really going international. So I'm beginning with Bhopal, India. Do we have a signal from Bhopal? Yes. Excellent. Welcome to NASA.
It's working.
Hello, everybody there. Wonderful to be talking to you today, all the way in India.
And of course, they don't have very good cameras in India, so we're getting a terrible image.
Later, yes. Yeah. Great to meet you. Hi.
Their bandwidth looks miserable, huh?
No, I'm just joking. And they have no lights in Oregon, so there you go.
Is anybody there? Hello, Portland. They're in an auditorium, I see. Okay, next we're going to go off to Milan, Italy. So afternoon in Italy. Do we have the feed from Italy?
Somebody's sweeping the stage. Oh, my God.
It's dark in Italy today. There we go.
There's about 12
So
people.
Is this Vermont? Hello, Vermont.
In
Well, that's
Vermont.
Vermont. Oh, love the hat on the left. Oh,
Yeah, Left Shark is ready. He's ready to go.
Going even a little bit further afield, we have Netanya, Israel. Hello.
Nice.
Hello,
And
Israel.
I think there are people all over the world who are really excited about these images.
Yeah.
Okay, and just one more for now. I see people like giving me hugs.
The image that
okay,
President
we also have
Biden
Vancouver, Canada. Hey, Vancouver.
showed.
Hi.
Canada, see, Canada's so far ahead of us. Look at
All these
that.
people with you.
Great
So,
picture.
Right across from the campus from me,
Not
there's
so
also
many
a huge
people.
watch party taking place with members of the Webb team. So the wonderful thing is that they actually are people that have worked on the mission, and they are.
I shouldn't mock.
They have the family. So hello,
Production is
Webb
hard.
team.
It's very hard. Although NASA is notorious for really good production. Maybe not as good as SpaceX, but
Although, you still do see on NASA TV occasionally a couple of guys in director's chairs with a ficus tree and a paper drop behind
Yeah.
them. So there's a little bit of
Between two
public
friends.
access TV going on there.
that's okay. I'm more interested in the science than the production value.
We'll say hello
Absolutely.
later in our broadcast. So now it's time to start the main event. What
All
we'll
right,
see over the
here we
next
go.
hour will be a collection of images newly processed by the Webb science team. Only a tiny handful of experts have seen the images so far, and I can tell you that we have been so excited to unwrap them for everyone. We will be releasing each image in turn in real time. As soon as you see it on this broadcast, it will be available for download on the internet. On the
How high
screen
res
below,
are these
you can see a
images
timeline showing
that
where
we're
we
gonna
are in
get
the
to
show
see? Are
and what's
they-
coming
I
up.
don't actually know.
By the end of the
I know
show,
that the
all
originals are
5
very high
images
res,
will be
but what they're going to
available
send out, I'm not sure, because I'm
So hopefully
imagining
you
they're
can
probably
tell
concerned
I'm
about
excited.
bandwidth right
Okay,
now.
So let's do this.
A lot of people signing up for the astronomy photo of the day, I'm sure. I actually use it as wallpaper on one of my computers because I always like to see these pictures.
Here's the driving needle drop music. Yes.
Yeah. We are in NASA.
Okay, we're going to release the first image right here at NASA Goddard Space Flight Center, Maryland. And we're just
exciting.
outside of Washington, D.C. NASA Goddard is home to the project office of the Webb Telescope. And the observatory portion of the telescope, the mirrors and the science instruments, were integrated and tested here before launch. So for many of us, including myself, seeing Webb come together bit by bit right in front of our eyes was an emotional and very inspiring experience. So it's kind of like a part of us was out there with Webb right now, a million miles away.
One of the things I
part of
love
our
about
hopes and dreams are
scientists
out
is
there.
they're
So I'm
like engineers. They're often just real people, not camera ready, and I love it.
Yeah.
That's I far prefer it. And again,
A
the
lot of
stream is
media
stalled.
coaching.
Lots of people want to watch this all over the world, of course.
Yeah.
As
So I
do
think-
we.
I think the first thing we're supposed to see is the Carina Nebula, which is one of the brightest nebulas. It's about 7,600 light years away. And that's the place where we saw that famous Hubble picture called the Pillars of Destruction.
Yeah.
I think it was also
Yeah.
the Fingers of God. So those are gas clouds, which are very pretty. But
Excellent
the thing about
wallpaper.
Hubble is
Yeah.
excellent wallpaper. Hubble can look through that gas, that dust, which is what creates that incredible image because it's being fluoresced by ultraviolet energy, and start looking at some of the stars and the star
a
clusters
very inspiring
inside.
experience. So it's kind of like a part of us was out there with Webb right now, a million miles away. Part of our hopes and dreams are out there. So I'm.
This is, I assure you, not just us. In fact, we're really trying to help at NASA by offloading some of the viewership to our stream so that.
And you're on
very
their direct
inspiring
feed, right?
experience. So it's kind of like a part of us was
Here we
out
go.
there with Webb.
We're on
right
the
now.
YouTube,
a million
feed, which-
miles away. Part of our hopes and dreams are out there.
I presume is going to be
So
as good as any.
I went on to the NASA TV Direct, and I don't see it
Ones we're
freezing
seeing
in
as
the
they
other
looked
window.
about the
All
time
right, maybe
the
we
sun
should
and the Earth formed.
try that.
Yeah,
And then
just search
behind the
NASA
cluster,
TV.
we have the cluster.
I think YouTube would have plenty of.
The gravity of the
course,
cluster
probably that's
is
where the most
distorting
viewership
and
is.
warping
Yeah.
our view of what's
So this is the
behind.
image from
So this is
yesterday.
the picture
there are
we
these
already saw,
galaxies
yeah.
that look
Yeah.
stretched
The
cluster, and the pulled. The kinda gravity of the like they've been cluster is magnified distorting because and they've been warping our view of what's behind. And so there are these galaxies that look
we're
stretched
switching,
and
right now,
pulled
switching
by the
streams.
gravity
Okay.
of the cluster. They've been
Just like
magnified
Einstein
because
said.
You got two
they've been
streams up, John.
magnified
And,
by the gravity
really,
of the
there's-
cluster, just like Einstein said they would. And it's really, there's so much detail here.
Here we
We're
go.
seeing these galaxies in a way that we've never been able to see before. There's just a sharpness and a clarity.
That's a YouTube feed as well.
And so we can look at, if we zoom in on this image, and I encourage you as you grab this image at home, like zoom in.
It's on the NASA TV website.
Really zoom in and play around. There are galaxies here in which you're seeing individual clusters of stars forming, popping up, just like
unfortunately that, John, means you have to click the YouTube.
We also see
you have to click that, and then you can go full screen. And
kind of littered like jewels.
John, I'm going to send you the link I'm using because I don't see any freezing going on there.
Red galaxies. Now, that was what we built the telescope to do. The most distant of those are billions of years. We're seeing as they looked more than 13 billion years ago. And so galaxies like that one right there, this little red guy, you're like, okay, yep, what is that? Well, Webb got spectra to figure out what those galaxies are made of, and this is that one. We're seeing as it looked 13.1 billion years in the past.
Amazing.
Less than a billion years after the Big Bang.
Look at that resolution.
And we're seeing the elements of oxygen.
That's what Pluto looked like by Hubble about
neon.
10 years ago.
This is how the oxygen in
Perhaps
our bodies
more important, you're getting the full
in
spectrum.
Stars, in galaxies, and we're seeing that process get started.
So you can see.
I want to give this a little bit of context.
The chemistry.
So this is now the farthest away galaxy that we have this sort of detailed information about.
That we know what it's made of.
We know what it's made of.
Yes.
And this was not a long exposure for Webb.
No, the previous record holder, right, the Hubble Extreme Deep Field, was 2 weeks of continuous work with Hubble.
Wow.
It was just imaging. With Webb, we took that image before breakfast. The amazing thing about Webb is the speed at which we can churn out discoveries. So everything that you're going to see here in this broadcast is a week, and we're going to be doing discoveries like this every week.
Amazing.
That is absolutely incredible, Jane. So thank you so much for joining us. It's been an honor to be working with you. Congratulations on all your hard work.
Thank you. It's so wonderful.
And if I could just add, the Webb works 24/7, whereas Hubble only works during the dark half of its orbit. So
from
it's going to be on all the time.
Closer. It's a planet, but not one in our solar system.
That we know what it's
Remember,
made of.
we know that Earth and its sibling planets aren't the only show in the universe. When scientists and engineers started developing JWST,
this looks like a better feed.
The search for exoplanets wasn't even part of the plan.
Yeah.
That's changed. Exploring exoplanets is now a major component of the mission and the subject of our second big reveal of the day. I'm going to send it now to our friends Natalie Willette and Sarah Gallagher at the Canadian Space Agency in Montreal. So again, bonjour.
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 Ça va?
I guess we're having a little...
Bring in the bridge music.
No, we're going to Montreal. Yeah, that's what's happening.
There we go. Kazoo.
Okay. I'm going to call and I'm
going to tell you... Go.
And roll.
Roll it.
Oh.
Sorry for the brief pause there. We're now going over to Canada.
So she's still alive, but they're not. They're buffering.
Okay.
It really is, I think, a measure of the amount of interest in this.
Yep. We're all ready.
Yeah. And
Okay,
so
I
you get the
apologize. We're having
numbers.
some trouble with the signal from
internet
Canada.
broke.
But luckily for us,
We
have
can
an
see
exoplanet expert
exoplanets,
in case that
but we
happens.
can't get
So this is
Montreal.
She's an exoplanet scientist at NASA, and we're going to talk about this amazing new result from a very
They had a
hot
backup
planet.
ready. That's
I
good.
understand about
So
1,000 light years
while they're doing this,
The exoplanet is named WST-96b, and it is this hot.
Oh, this is good.
Her mic's not even on.
planet That it is about 1,000 light years away. So that's why today is really.
This is WASP-96b she's talking about, which is that hot Saturn I was telling you
She's
about.
actually not wearing a mic, I know.
So talk us through
Yeah.
what this discovery is and why this is so significant.
That's how
Well,
fast they.
this
There we
reveal
go.
that you're going to see is going to show the first spectrum of an exoplanet as taken from the Webb telescope. And this is exciting because it covers
Presumably
infrared
she's seen
wavelengths
this
of light
image.
that we have not had access to
think
before.
she's on the
so
team.
we've been able to use other telescopes to explore
Hold on.
exoplanet atmospheres in the infrared, but not to this level of detail. And this is just one sliver of data that Webb is providing us using the nearest instrument specifically.
And there's something about infrared that is actually particularly good for the spectrum. So in this case, what we're doing is we're actually going to take the light and break it up into a rainbow and look very, very carefully at how much color is coming in each part of the spectrum. So I believe we've got that image. If we can put that up.
Okay, yes, I believe we're revealing the spectrum right here. So we now have our spectrum.
We don't have the picture, but
this is exactly what you're seeing as you just described with spectroscopy. What we did was we observed a transit of an exoplanet. We observed the planet as it passed in front of the star. Now, mind you, this is not a direct image. This is an indirect image. So we've seen the effect of what happens when the planet and its atmosphere passes in front of the star. The starlight filters through the atmosphere, and then you can break that down into wavelengths of light, and you get a bunch of what looks like bumps and wiggles to some people, but it's actually full of information content. So you're actually seeing bumps and wiggles that indicate the presence of water vapor in the atmosphere of this exoplanet.
Wow.
So we have the spectrum up here. Is there anything you'd like to highlight particularly?
Yeah, absolutely. So we have several features marked here.
It's only
so I call them
in the last few decades we even knew that these planets existed.
Wiggles.
That's
what
right.
you're seeing here is a telltale signature.
And it's a little surprising there's that much water considering how close it is to its host star.
In the atmosphere of this specific exoplanet. And the other thing we can tell
it's almost
actually
2,000
that
degrees
there's
Fahrenheit.
evidence of clouds and hazes because the water features are not quite as large as we predicted. So we can take that and infer that there are presence of clouds and hazes.
Right. Now, one thing that we really want to make sure people understand is that this particular planet, this is a hot world, is actually closer to its star than Mercury is to our sun. And so we're not looking at liquid water here, but we're looking instead at sort of steam, water vapor.
Yes, this is an exoplanet.
There you go.
About the size of Jupiter, about half the mass of Jupiter. It orbits around a sun-like star, but it does it every about 3
How important is the discovery of water? I mean, I know when we're talking about water on our nearby planets, it's useful for fuel down the road. Is it an indicator of life?
Well, it's an indicator of potential for life, although, as they had said before this broadcast, at that temperature, life would be a surprise. But life surprises us. You know, extremophiles are constantly surprising people. They had assumed it would be a cloud-free atmosphere because it was so high in sodium.
Wow.
But apparently not.
Is not only are we going to be looking at planets that are more like the Earth,
but a 3.5 day orbit. I mean, think of that. Mercury is very close to the sun, and it's 88 days. So this is like skimming that star practically.
Stay tuned for a lot more to come.
Thank you so much, Nicole. Thank you so much for telling us about the spectrum. And I'll be
so if water's on this planet, it seems highly likely that water is a common element in the universe, I would guess.
Yeah.
But
I mean, what are the chances we happen to hit on the one planet that had water?
Right. Well, especially one that we would assume would be so
we wouldn't
hostile
expect
to water vapor.
Yeah. I think that's by itself fascinating and important discovery.
So I think they put that up front because it's the only squiggly line science image they were going to show. The rest of them are going to be optical images. That was the one where they had data, but you know they have not yet imaged an exoplanet with this thing in terms of looking.
So there are many cameras on this telescope, and they have each different roles to play.
Yeah, there's only a couple actually, but they have 4 main instruments. But 17 different observing modes. It's kind of like your sophisticated Nikon SLR with all those settings, right? So they just finished calibrating the last of those different observing modes on Sunday. So it's really ready to rock. And I bet these guys are just jumping out of their pants. They could go.
Right? You know you're the last one to touch this.
So some of the things they're looking at different areas of the visible and invisible spectrum. In fact, I think that probably many of the images we see, the optical images we see, are corrected and colorized.
Yeah, they have to be because they're all infrared.
Right.
So
they're not visible light.
In the infrared,
yeah.
right?
Yeah.
But they make them pretty before they come out. And there it is. Look at all that mylar. All that thin, fragile mylar that deployed perfectly.
That's the sun shield, right? To keep it from overheating.
Yeah, it's 5 layers separated by a couple inches each. And they had to not only unfurl to the sides, but then they had cables and pulleys that had to pop them apart from each other to create this little, space of vacuum in between.
Yeah.
And I still,
awesome.
I know it's been a long time, but the fact that this thing worked just still blows me away.
Unbelievable.
Yeah.
And worked 100%, right? There was no part of it that didn't work perfectly.
Glitches. No glitches.
Amazing.
The only glitch they've had so far is they had a larger micrometeoroid impact on one of the mirrors than they expected, but it's well within the range of what it can survive and still work fine.
Presumably throughout the life of the Webb, they're going to get impacts all the time.
Yeah, because part of the thing about the Lagrange point is because it's a stable orbit, it tends to attract a lot of crud. Yeah. And, even a dust particle at those speeds can cause you significant damage, but most of it's just going to end up punching holes in that thermal shield, and they're going to be tiny. So as long as it doesn't tear for some reason, you're in good shape. But, those mirror segments had to close within angles. When we were talking to Mark Clampin last week on the podcast, I thought it was something small, it's smaller than the width of a human hair, but he said, no, hundredths of a width of a human hair.
Wow.
That's how exacting it has to be. And that's why it's
precisely
only calibrate.
Yeah.
Oh my gosh. Yeah.
Now,
these little tiny stepper motors and pistons doing all the work.
On that first image, we saw, I don't know what you call those, starbursts coming off of that central image. We see them there again. Is that an artifact of the telescope?
Those are usually artifacts of the support struts that hold up the secondary mirror. It's like being diffracted by them. Yeah. And I don't recall how many struts are on the Webb secondary, but that is my presumption.
So it's kind of like the bokeh that we see in a camera from the
it's kind of an artifact.
Yeah.
I'm Alex
They just put up a coming up next message. That was kind of weird.
Carl Gordon, who is an astronomer and one of the key people in delivering the images that you're going to see here today. But actually, before we get into the amazing images, we're going to talk a little bit about where we are.
Not yet.
We're sitting here outside of the Mission Operations Center, which is the key central hub for Webb.
Yeah.
For the past
and
6 months,
the reason that there's a lot of this, and there always will be, is because you need funding. And you've got to get the American people excited about this so that Congress then votes money for it. So write your member of Congress and say, yes, this is important.
Yeah, and I was just reading a recent survey, some data last night from a recent survey, meta survey actually. They're constantly surveying the public's attitude towards space and towards NASA and the moon mission and so forth. And it's much worse than we thought. I mean, the percentage of people that really understand what's being done out there is tiny. Yeah. And interestingly, as you move to millennials and younger people, there's much more fear of space and even space exploration than there is optimism. So our generation was raised during the space race, the go-go years, and we think this stuff is great. And younger people tend to think more about alien invasions and things falling out of the sky and so forth. So there's an education gap here that needs to be bridged. Yeah. We're doing our part today. But you're right, NASA has to constantly stump for funds because they don't just have the public to keep happy, they have Congress to keep happy and the executive branch to keep happy, and that's a never-ending job. And I work on some of that stuff, and it's very carefully crafted, I can tell you.
Yeah, I know you were at JPL, you did public relations for JPL.
Yeah. And we do a book every year that goes specifically to Congress and the president. And it's very honest, and there is science in it, but there's a lot of
got to sell it. I completely
description in there about how hard it is. Yeah,
and you got to sell it. Big science is remember we were going to build a super collider in Texas, and
yes,
it got defunded, and unfortunately, of course, CERN, thank goodness, is thanks to the EU, is operational, and all the science we're getting from that.
Well, and we were going to send humans to Mars in the 1980s.
Yeah.
And it's still a few years off.
So it's always on and I understand there are many priorities, for government budget, but this is a relatively inexpensive thing that a government can do, and so important.
Yeah, and the next big space telescope, which I hope they'll talk about at the end of the broadcast, is called the Nancy Grace Roman Wide Field Space Telescope. And it's got an interesting story behind it. Maybe we could talk about later if we have time. It was kind of actually a used telescope that they repurposed for a new mission.
Wow.
And it's going to be able to do some stuff that even the Webb can't, even though it's much smaller.
We're basically translating light.
Okay, show us the pictures.
Into light that we can see by applying
never talk about process
red,
here.
Blue to the different
which is good because this is what we were talking about earlier.
And the reason why
they turn this
the
into something
images is
we can
because
see.
there's actually more that you can get, more information that you can get from the image if you see it in color.
So it's a matter of picking and choosing filters and colors that enhance the details and the structure in the image itself.
The shortest wavelengths of infrared light and assign those blue colors, and then move our way down to green and red as we go to longer.
It's like he's using Photoshop or Lightroom.
Additively combine those together to get our full color image.
But there is a lot of aesthetics that are involved in this.
Like the affinity
painstakingly
photo.
going through and cleaning these images up with an attention to detail, a level of detail like at the pixel level in every image.
So when I'm working on the astronomical data, it is this sort of marriage between art and science. When you're choosing colors for the filters, you really are trying to show the different details and the processes that are happening in astronomical images. But at the end of the day, you want it to be very compelling. You want it to be very beautiful, because space is beautiful.
And after those images were processed, there was a select few of us, very lucky few of us, who got to see the first images.
Oh, don't tell us that.
Those is downscaled by a factor of 4.
Oh my God, look what you're seeing. It's amazing.
So we have
and us and nobody else.
People who are producing these images, and we feel incredibly privileged.
Can you make that star purple? I think it should be
We're
purple.
the first to see these science-like images. When we saw the first data come down of real targets,
look at how happy they
people
are.
were speechless, and there were emotions. Because
in
we
fact, one
immediately
scientist said he was in tears.
how amazing this observatory
I can only imagine.
The detail, the sharpness, the depth. And when we saw the first color images, we knew that we had a winner.
It's like Casual Friday there.
And now we are ready
I think it's always,
to see Webb's
Casual
first
Friday.
image of a star dying.
Here we go.
A planetary nebula called the Southern Ring. Let's do it.
Oh, look at that.
Look at
wow.
that.
There's your desktop wallpaper.
Wow.
That's a gas cloud around a dying star
near-infrared
half a light
images.
year in diameter.
Wow,
2,000
the
light years
detail.
away. 3 trillion miles across.
Unbelievable. That's
For comparison, our solar system is about 5.6 billion miles. So that is a big
Wow. Okay.
cloud.
Well, here we are. We have a
Unbelievable.
near-infrared image on our left, or on maybe your right. And here on the right, we have a near-infrared image. And so I'm here with Carl, our astronomer specialist. Can you tell us what we're looking at in these
So you
images?
can see it's punching through a lot of that
Planetary
dust.
nebula. It's caused by a dying star that has expelled a large fraction of its mass over in successive waves.
Okay, so we actually see those waves in these images.
Yes.
Wow. And so there's a lot of structure. Can you tell us a little more detail about what we're looking? Maybe start with this one on the left.
Yeah. So in the NIRCam image, you see this kind of bubbly, almost foamy appearance throughout
screen,
the whole
please.
nebula with some very structured shells.
There we go.
There we
But
go.
and
That's
this
not the left
foaminess
screen
is
image,
showing
but
up in
that's okay.
orange mainly, and this is due to
Look
the
at that.
molecular hydrogen that's newly formed in the expansion, just lighting up the gas and dust of this nebula.
So
And then
the
as we
gas
move inward,
actually
you see this kind of very
fluoresces in the
blue
UV.
haze in the
Does
inner
it really?
region.
Wow.
And this is
Yeah.
actually due to very hot
That's how
ionized
powerful
gas
that
that emits
central area
well
is.
in the blue, that's heated by the core, the leftover very hot core of this star.
And what about these like rays that I'm seeing in this image?
Right there. So there's also rays in the outer regions that you can kind of see, and these are holes in the inner nebula
So
that
is-
are actually allowing the central star's light to come out and kind of light it up like patchy clouds with the sun shining through.
Wow. Oh, yeah.
they
This is
estimate
not a
that's
star that's gone
so
nova.
cool.
This is not the after effect of a
So
nova.
you're actually a
No.
mid-infrared
This is just
astronomer, which is different than near-infrared.
Matter
And
emitted
so
by
what
the
can you
dying
tell us
star.
about the details in
Yeah.
this mid-infrared image?
Now, it may have
So
already
this
gone
is-
nova,
it
I
looks
don't know,
quite
but
different in
that
color.
gas is expanding at 9 miles
We're
per
seeing
second.
different
So we're
kinds of
actually
physics
seeing
going on here.
something
So we're actually
in
seeing the
motion
blue. You see a
here.
lot of blue.
Right.
The blue is actually due to hydrocarbon grains that are emitting very strongly in the blue for Miri. And they show the very similar structures to what we see in orange and NIRCam because the molecular hydrocarbon actually forms on the surface of dust grains. And so again, as we move inward, we see that the inner region is again hot ionized gas, but now it glows red because that's where it emits the strongest for Miri wavelengths.
Okay.
And then as we go into the center, we see kind of the surprise for us, which is We knew this was a binary star, but we effectively didn't really see much of the actual star that produced the nebula. But now in MIRI, the star glows red because it has dust around it. So in MIRI, we got to see both stars very clearly.
Yeah, you can't see it in the first image really, but there's 2 stars there. So that's a fun
surprise. Need Alex Lindsay to produce these.
And I think that there's another little Easter egg.
Who's asleep on the soundboard there?
Yeah,
they totally need Alex.
The Easter egg is this kind of narrow filament up in the top that's radially aligned. You can kind of see it very clearly in the MIRI image. It shows up as this blue structure, and it points very much to the central sources. So I thought, oh, this must just be a density enhancement in the outer nebula. I thought that very, very strongly, but other people on the team were like, no, it's a background edge-on galaxy. Well, I made a bet that said, no, it's part of the nebula. By the way, I lost the bet because then we looked more carefully
at both
edge-on
galaxy
and MIRI images, and it's very clearly an edge-on galaxy with a dust lane.
Unbelievable.
So I lost the bet.
Well, you lost the bet.
Good bet to lose.
Gorgeous images.
Yeah.
So I think it's a win for everybody. Anything else
That
you'd
is a
like to
win.
say today?
I can't wait to see where we go from here.
Neither can I. All right. Thanks so much. Back to you, Michelle.
Really stunning image. That should be the A-pod.
That's a beautiful one.
That is.
And it's beautiful at any wavelength.
Yeah.
Thank you,
back
Alex
at Goddard
and Carl. I
now.
have to say that image is absolutely spectacular. So as you know, people from all over the world are watching us today and joining in our excitement as we release Webb's first science images. We've been checking in with our colleagues in Europe and Canada throughout the program, but we also want to take a moment to include the people at the oh-so-many viewing parties scattered around the world like stars in the night sky. So let's check in with some of them now. First, we go all the way to Perth, Australia. Do we have a signal from Perth?
Sky.
I guess nothing from Perth right now. Maybe we have some of our
It's just so ironic that we can get these images from literally billions of miles away.
Yeah.
Billions of light years away.
Australia. There's Perth. Hey, waving to Perth, Australia. Thank you so much for
Yeah,
joining us.
but they're not moving.
Next we go to
in
Winnipeg,
awe.
Canada.
There they are.
Hello, Winnipeg.
What?
At a planetarium.
That's
Everybody's enjoying
Winnipeg.
the show, I hope?
Sit up.
Okay, Dayton, Ohio.
Oh, come on. We're really here.
Anybody.
We're here to see
Hello,
the
everybody.
pictures. Come on.
Nice to have you here with us. There we go. Yes.
Too many empty seats in that one. Switch off.
They're jumping up and down.
It looks like a planetarium.
Okay, all the way back.
Yeah, I think a number of these are planetariums, aren't they?
Bangalore.
Yeah, or museums at least.
Hello,
Everybody's leaving. Hello, Bangalore. Goodbye, Bangalore. Yeah, we have to go back to school now.
Absolutely wonderful. Hey.
Yeah, but they are so excited in
India
and Pakistan about this stuff. We get a lot of those students every year at our conference, and they are just
Good.
energized.
Good. I'm glad somebody is.
California. They're on site to celebrate with us.
It's JPL.
So, hello, JPL.
Oh, it's JPL.
Some of my favorite
Good
people in
morning,
the world.
JPL.
Hey, hello. And
Pretty
I think
good
the last
showing
place
for
we're
this
going to
hour of
right
the day.
now is Northrop Grumman, one of our
Not
major
bad.
contractors. Hello, Northrop Grumman.
Oh, they're
hey,
excited.
all
They're saying it worked.
They built
It
it.
worked.
They built it. Yeah. Yeah.
After all those tests that failed,
Nice
it
to see you,
worked.
Northrop Grumman. All right, now there's also a big watch party right here on the NASA Goddard campus. Many of these people have worked on the mission itself, and we also.
Hey, John, can you move the
leadership
Discord
represented
news
small
channel up
government.
so that
hello.
and I can tell
Hello,
people,
watch party at
come on, let's
Goddard.
go.
Yay!
Well, their local feed looks good.
Okay, wonderful. So, I mean, at NASA, we are so fortunate to have all of these friends and colleagues around the globe. A major partner in the Webb mission is the European Space Agency. ESA
There you go.
contributions have been essential to so many aspects of this project, including Webb's spectacular launch on the Ariane 5 rocket last December. I'm very pleased to turn over the show for a few minutes to Katie Haswell. She's joining me from the European Space Operations Center in Darmstadt, Germany. Hello, Katie. Good afternoon.
Thanks, Michelle. Thank you, Michelle, and welcome to Germany. We're at the European
Just to note,
Space
guys, I'm still getting all kinds of IFB from lots of people.
Center.
Yes,
where the
we
teams
are too,
effectively
as a matter of
fly
fact.
the satellites. They're a little bit of a cross between air traffic controllers and pilots. We have lots of different control rooms here. This is the
How many
main
images
control
do they
room,
have
as
to
you
show
can
us
see
today? Do you
it's
know,
not in
Ron?
use, so we've
A
been
total
lucky
of
enough
5.
to,
So we've
move
seen
in
Okay,
here.
so they're
watch
stretching this
squiggle.
out a little bit.
Yeah, so I think now we are down to the Carina Nebula and Stephan's Quartet, which is that one we talked about from It's a Wonderful Life.
So that we've seen 3 of the 5 so far. The first one President Biden showed yesterday, we saw the second, which was merely a spectroscopic image. And then the third one, the dramatic, very beautiful
Ring Nebula, yeah, that was spectacular.
Yeah. How far away is that? You said 2,000 light years?
The Ring Nebula?
Yeah.
Yeah, just under 2,000 light years away.
Because we've come here today because these guys were the first ones.
That's far away.
Pick up the signal during the.
But at not a billion light years away, so.
That's true.
3 billion light years away. It's really kind of remarkable.
13, yeah.
Is 2,000 light years considered our neighborhood?
I guess so. Yeah.
When you're on that scale, is it in our galaxy? Whoa! Look at that. They're all happy about something. Maybe that was when they unfurled the.
You got to be truly exuberant to have those kind of hugs in Germany, I think.
I think so. Yeah.
On board the awesome Ariane 5 launch vehicle from the Guiana
that was
Space
the
Center.
launch.
The atmosphere in the mission.
Oh, yeah. That makes sense.
Electric, I can tell you, I was there. They've also provided people. We have 15 ESA scientists working at Space Telescope in Baltimore, and also they have provided the infrared spectrograph.
I've piled the camera on 2 very thick Python books, but
the Miri.
They're not as stable as I was hoping.
That sounds like my setup.
This includes NIRSPEC, the near-infrared spectrograph led by ESA. NIRSPEC splits near-infrared light from astronomical objects into its components. Like a barcode, this will help scientists understand the physics of the objects they're observing,
like a
from their
barcode?
temperature to atomic makeup. NIRSPEC can observe
that could have been a little more creatively phrased, huh?
Like a barcode?
An image slicer.
You mean like a
and an
spectroscope?
array of microscopic shutters. Webb's integrated science instrument module, located behind the main mirror, also contains MIRI, a mid-infrared camera and spectrograph. Seen here during testing, MIRI's been developed by a partnership between Europe and the US. MIRI detects mid-infrared light from planets, stars and galaxies. It can analyse molecules to help us deduce what astronomical objects are made of and peer into clouds of gas and dust where stars and planets are born. Together, these instruments will help Webb detect and analyse light from the very dawn of time, revealing the universe.
That sounds so much better in an English accent. The very dawn of time.
But everything does.
So
everything does, yeah. So
let's get ready to reveal our image. And remember that one of Webb's jobs is to find out about galaxies, more about the galaxies, but also to help us to understand how they change. And this image is going to be very, very useful for that. Let's reveal it now. There it is. It's called Stephan's Quintet, and it's wondrous.
Oh, there
Giovanna,
it is.
what are we looking at?
So this is
way better than it did in the movie.
So we are looking at 5 galaxies.
This is where the angels get their wings in
That's right.
life.
Every time somebody rings a bell.
Everywhere around us in the universe, they contain from million to 100 billions of stars.
So is this 4 galaxies we're looking
at? One of them, the Milky Way.
There's actually 5, and 4 of them are actually in relatively close proximity, then the 5th one is much closer to us, so it's just an embarrassing.
And these 4 are at a distance of about 300 million light years from us, and are locked in a close interaction, a sort of cosmic dance driven by the gravitational force. You can
Most of the
see
science of these comes not from the optical images. You don't, right? You don't have scientists poring over these with a hand lens.
Area to study because
And both, but spectra is really the big winner here. Yeah. These are these objects are expected to merge at some point in the distant future. And I was saying 4 of them are
They're being drawn together by their gravitational fields.
Right. And those 4 are about 290 million light years. The 5th is between us and them, and it's only 40 million light years. So
it's just basically like somebody's head in the way.
In universe, in intergalactic range, I guess that's a fairly close neighbor. Yeah.
The galaxies in the merging galaxies.
They think that the wispy tails indicate violent interactions from the past between these objects, sort of tearing each other apart.
So we're actually seeing the process of creation of new stars in this region.
Will they also do images separated in time to kind of get some sense of the movement?
Well, it's from this vantage point, it's like, distant object parallax, right? Takes so long for things to change that unless you're looking at something like a supernova, it would take many, many, many hundreds of years to see much of anything. So I don't really think that's a priority. The priority is the sky's a big place, and there's so much you want to see.
Let's
right?
get as many images as we can.
Yeah, and the proposals have to be filling entire rooms at this point if they printed them out, or hard drives if not.
Exactly. So
because there's a lot of people who want time on this machine.
There of the stars predominantly now in the mid-infrared with MIRI alone, we see mostly gas and dust. So we see the same galaxies.
Oh, that's interesting. They image it with two different cameras.
And then we also see something very interesting up at the top here, because this top galaxy has something new and bright in the middle of it. And Giovanna, tell us what that is.
Yeah, that's an active black hole. We cannot see the black hole itself, but we see the material swirling around, being swallowed by this sort of cosmic monsters.
That's that bright object to the upper right.
This gas gets heated to extremely high temperature as it falls onto the black hole, and it becomes very bright. In fact, this is how shiny is the galaxy. Here we see luminosity that are 40 billion times the luminosity of our sun. Really bright. And with NIRSpec, we can zoom
That's a bad day in Phoenix
into
right there.
this area. And we have this technology that allows us to take thousands of images at different wavelength channels.
Oh, you can see the different wavelength images at the bottom. That's cool.
This distribution of the gas, what's going on in the gas in different regions of this core area, and understand the composition of the gas, the velocities, the temperature. So that's very important to understand the physics.
So it's giving us so much information, and it just shows the power of this telescope. Mark, this is just the beginning, though, isn't it?
I think that's a very important takeaway from today. These are like pictures just taken over a period of 5 days, and every 5 days we're getting more data, which will contribute more in that direction. It's a culmination of decades of work, but it's just the beginning of decades.
NASA will make all of these images available for download.
Is essentially that we're ready now. This telescope is working fantastically well.
So we can really look at them more
to borrow a phrase from a famous rock musician, we're ready to turn this telescope
on
up
your
to 11.
Big monitors.
It really is time. It's fantastic.
Thank you very much indeed, both of you. Back to you, Michelle.
This may get me to finally buy a nice big monitor.
Thanks, Katie. It was so great to have you and your colleagues with
long.
us on this historic day. So before we get to the fifth and final image reveal of the day, it cannot be said enough that an achievement like the James Webb Space Telescope is something bigger than any one of us. It's bigger than any organization.
So
any
webb.nasa.gov
Webb belongs to all
is
of
where
us.
these images
And starting today, the discoveries start, and they're not going to stop.
In fact, I'm looking at the image we just saw.
We've said several times throughout the broadcast that the Webb mission is about people.
And if you look at it full width, it
during the
is
construction of the great
nice and high resolution, and you can really see those five galaxies. It's really dramatic. They're also posting it on Flickr. The highest quality image that they're offering.
Oh, fabulous.
Huge.
These photos are
it's 2408 or 2048 by 1717. But big enough for your desktop for sure.
Although I haven't checked yet, they did direct us to for most of these to go to JWST.nasa.gov as well.
Oh, okay. All right. The Flickr actually has the photo in all sizes.
That's probably the best place, right?
Yeah. Believe it or not.
Let's hear it for private enterprise.
Yeah.
You're on.
Okay, it's time now for the last image to be revealed. Here we go.
All right.
Again with the music. Starburst.
Same piece. This should be the Carina Nebula. So this will be 7,600 light years away. some of the largest and youngest stars in our galaxy. So this is relatively
Amber
close.
Strawn is Webb's deputy project scientist. She's here with me today to share the final big reveal of the day. So Amber, it is so good to see you. How are you feeling?
Oh, so great, so exciting. What a great day this is.
Yeah, so one of the things that we're going to do is before we get to the final image, the James Webb Space Telescope has taken us all over the universe today. So let's do a quick review of where we've been so far. So Jane Rigby got us rolling today with an extraordinary
These images
image
on Flickr are just gorgeous. Highly recommend.
Yeah, this image really does demonstrate that JWST can do exactly what we designed it to do.
I guess I'm going to need 3 monitors now.
And the Canadian Space Agency then took us to the massive planet WASP 96b, where the team has detected evidence of atmospheric water.
And here again, we're seeing the incredible efficiency of this observatory. We're able to do these kind of measurements in a fraction of the time that were able to before.
And then
12
we
hours.
From NASA Goddard to the Space
They did
Telescope
that in
Science
12 hours.
Institute, where Alex and Carl showed us the exquisite southern Ring Nebula, a mixing bowl of stellar matter around a pair of dying stars.
Yeah, and I'm just blown away by the level of detail we can see, like in the outer part of this nebula. It's incredible.
Wow. Okay. After that, it was off to Germany, where the European Space Agency wowed us with pictures of galaxies interacting and mixing together.
Right, and this image, again, it's incredible because it's showing us one of these fundamental processes of the universe, how galaxies merge together, and we're able to learn about these processes in a brand new way.
So the Webb team has a lot to cheer about right now. So across the campus, there's this big watch party, and we can feel the excitement all the way from over here. So let's join that celebration.
They didn't spend a lot of time on that image.
John Mather, along with the head of NASA
and they're riffing to show before they show the last one.
Yeah. Oh, they still haven't shown it. All right.
Yeah. That's a bunch of happy people. That's not just a bunch of sleepy kids. Those people worked on it.
No, yeah, these are the...
So, John, we looked around
They're
the
dressed
world
in
and we're
suits.
the only ones with a cheerleading crew right over there. That's amazing. Look, you've been with this mission for decades. How do you feel today?
I am so thrilled and so relieved. This was so hard, and it took so long. It's just impossible to convey how hard it really was. We risked so much to say we're going to go do this, and it's so near impossible, but we did it.
Yeah, there are thousands of ways this can go wrong.
And just getting it out to L2 was such an achievement.
We worried about and frankly feared even after launch. I have to tell you,
it's almost 1 million kilometers away
really,
from the
really
Earth.
nervous, and it's almost like athletics for me. You
and
always
how many minutes
like
does it take? 1 million miles. Sorry,
yeah. The signal should only take a matter of seconds. The moon's about 1.5 seconds away, so probably 6-10 seconds.
Yeah, that's difference between the two of us. I always worry.
Although I imagine that these images are taking some time to send. I don't know what the bandwidth is.
But the data has got to just be a huge mass, right?
Bill and Scott and Greg talking about the team that is there. I think what's also important is to recognize that Bernie is sitting there. He was the first manager. I was sitting there. Could you stand up? And I want to mention that Phil
the bandwidth,
the manager, also during that time is no longer with us, but his heart is with us today.
Bandwidth actually is up to 28 megabits a second, so it can be quite fast.
So the Webb is 1 million miles from Earth, give or take, so more kilometers. Radio signals take 5.4 seconds each way. That's pretty quick. That's a lot easier than talking to Mars at 8 to 15 minutes.
I am just so thrilled that we had a privilege to assemble such a brilliant team. We drew from the best of the best, and here we are. So my extreme deep thanks go to all the people who built that team.
It's capable of sending 57.2 gigabytes a day at a maximum of 28 megabits.
And then when we didn't have...
That's way better than my upload speed.
That's pretty good. Yeah, that's a significant amount of data.
I feel shamed. I'm internet shamed.
And here we are. We have the support of the country and the world to take on this immense challenge.
You know what I'm most excited about? There's tens of thousands of scientists, and frankly, some of them just got born or not even born.
So John Arnold and our nobody's bored. John Arnold in our chat room is asking, as I did, about the starburst around the images. Can you explain that again? It's from the struts on the telescope?
I believe those are from, if you've done much astronomy with a reflecting telescope, so you have the main mirror, and then you have a little secondary mirror. So the main mirror focuses on the secondary, and the Webb's built the same way. The struts that hold that secondary interfere with the light and create diffraction patterns. What puzzles me is there's, I think, 4 struts on the Webb, and there's 6 diffraction rays, so there must be something else at work there. But that's traditionally what those come from. Yeah.
Image reveal.
And they're very hard to get rid of.
Absolutely.
Last image.
Here we go.
The big reveal.
Oh my
Last
God.
image is.
And that's why they saved it for last.
Look at that.
Carina Nebula.
So, Amber, can you tell us a bit about what we're seeing here?
Of course. This stunning vista of the cosmic cliffs of the Carina Nebula reveals new details about this vast stellar nursery. Today, for the first time, we're seeing brand new stars that were previously completely hidden from our view.
There's something you want to point out here?
Absolutely. So honestly, it took me a while to even figure out what to call out in this image. There's just so much going on here. It's so beautiful. One thing that really stands out to me is you sort of get this sense of depth and texture from this new data. There's a lot going on. To call out a few specifics, first of all, in general, the Carina Nebula is a nearby star-forming region within our own Milky Way galaxy, about 7,600 light years away. And in this view, we see some great examples, first of all, of hundreds of new stars that we've never seen before. We see examples of bubbles and cavities and jets that are being blown out by these newborn stars. We even see some galaxies sort of lurking in the background up here. We see examples of structures that, honestly, we don't even know what they are. Like, what's going on here? The data is just so rich.
And there's something really special about the infrared. Infrared can actually see deeper into these star-forming regions.
Absolutely. That's one of the great things about infrared is it really does reveal what's going on here in a really cosmic sense.
It's almost, you can see through the clouds.
And in general, what's happening in sort of this overall landscape is we have these gigantic, hot, young stars up here to the top of this rim, and the radiation and stellar winds from those stars is sort of pushing down and running into all of this. This is gas and dust. And of course, we know that gas and dust is great raw material for newborn stars and baby planets. But there's a flip side to this story and also a little bit of a mystery, because these same processes can serve to sort of erode away this material and stop star formation. So we have this sort of delicate balance going on of new stars being formed, but at the same time, the star formation is being halted. And for me, when I see an image like this, I can't help but think about scale. You know, every dot of light we see here is an individual star, not unlike our sun, and many of these likely also have planets. And it just reminds me that, you know, our sun and our planets and ultimately us were formed out of the same kind of stuff that we see here. We humans really are connected to the universe. We're made of the same stuff in this beautiful landscape.
And actually, the Carina Nebula is one of my favorite images from Hubble. So Hubble looked at this as well, right?
That's right.
Absolutely, yeah. The Hubble image of this is also spectacular. We saw it in a different kind of light when Hubble
look at the
took
difference.
an image of this
Holy cow.
particular nebula.
Yeah.
And then you can see amazing
Look at the
things with
difference.
Hubble, but when we zoom in to
Holy
this new
cow.
image, we're able to see so much more detail. And of course, all of us, you know, I grew
Looking
up
through all that dust.
on Hubble, and all of us love Hubble. And I'm so excited to see what these two amazing observatories are able to do really in tandem with each other.
Thank you so much. And again, congratulations. It's been a pleasure to be working on this with you. I'm just amazed by what's been going on.
I am too. Thank you.
This image is interesting because it's both beautiful on its own, but it's rich in scientific information. And, you know, I think sometimes they show the most pretty stuff so that we can make it our desktop wallpaper. But this clearly, to be able to see stars being formed and brand new stars is hugely valuable to help us understand our own origins.
I just sent John the equivalent telescopic photograph taken from a large telescope on Earth, and your jaw's going to drop when you see the difference.
Unbelievable. What an image. And that's just 5 images. And as I said, 58 gigabytes a day coming down to us from this amazing telescope. What a success. It's just unbelievable.
Or science.
Unbelievable.
Or risk-taking.
Mr. Nelson's got to be very happy.
And we don't
Who is he?
This is Bill Nelson. He's the former senator and now the NASA chief administrator.
For humanity. In the words of the famous Carl Sagan, somewhere something incredible is waiting to be known. I think those words are becoming reality.
Quite
Thanks,
moving.
Michelle.
An honor to have you here. Thank you very much. Wow. So
what a great time to be the NASA administrator, right? And this thing's been in the build for 25 years
to talk about.
Wherever you are, wherever you are.
Although
this is your telescope.
A little setback on the Falcon yesterday. I think they had an explosion.
Part of their lives
it was the Starship down in Boca Chica.
Starship, I mean.
They had, it was a gas fire. It wasn't that big a deal, but there was some damage,
This broadcast is a joint effort.
Nevertheless, that's par for the course. That's what happens.
And that's what happens.
Reach for the stars. You're gonna have, you're gonna have a few hiccups along the way. But man, we are blessed to be able to see these amazing images. 5 images from the Webb telescope, the first of many, many images. Now the battle begins with scientists trying desperately to get their few seconds on the Webb. It's probably too early to say what we have learned from these 5 images, but I think you can get a pretty good idea of the kinds of things we might be able to learn. And certainly from that spectroscopic image, the surprise already to see water in any form on a planet that's 2,000 degrees. Did you Fahrenheit or centigrade? I guess it does at that temperature. It doesn't really matter.
It's really hot. And something they're going to be able to do with this telescope that has always been a challenge before. It's got a coronagraph on it, which is basically a metal shield that will block out the star image so you can see planets next to it as long as they're in the right configuration. Yeah. And they'll be able to track the temperature profile, if it's a rocky planet especially, the temperature profile of the surface as it orbits the planet. So as it's coming near to go in front or behind it and then leaving the other side, you'll be able to track the temperature changes, learn something about the atmospheric composition and also the rock mass below. So while direct imaging is going to still be a challenge, they'll be able to do some, but it's really the spectra that's the most sensational, and then watching the heat profiles as these things change position.
And to give you an idea of how much progress we're making, it was always wondered, I remember vividly, are there exoplanets? Are there other planets on other stars? And it wasn't until 1992 that we verified that. And that was a huge step to say, yes, it turns out there are other planets. And now, of course, the search begins for planets like ours, for life on those planets. And this is going to be a huge benefit to detecting atmospheric components and so forth on these planets. Do you think we'll find a habitable exoplanet?
Well, it kind of depends on how you define habitable. I think we'll find exoplanets that demonstrate habitability potentially for extremophiles, probably talking about microorganisms here. In terms of habitability for human beings, that's a much taller order. And, part of the problem in doing that is you need a planet out in the Goldilocks zone, so it needs to be significantly further from the star than any of the ones we're looking at so far. So they're harder to observe. They have longer orbital periods and so forth, but they are going to be focusing on TRAPPIST-1 pretty soon, which is that star system that has, I think, 7 planets orbiting around it, and 3, depending on how you look at it, 3 to 3.5 of them are within the so-called Goldilocks zone or the habitability zone. So that's going to be a big moment when they get a good look at TRAPPIST, which is something we've been watching for a long time. That's got to be very high on their list of priorities.
And of course, one of the things they'll be looking for is liquid water, not steam.
Right.
If you read a lot of science fiction, I think, the phrase carbon-based life form.
Right.
They may not be the only forms of life in the universe, but certainly water is a prerequisite for that.
Well, that was something interesting when we were talking to the gentleman that came onto the podcast 2 weeks ago now. he was talking about the almost kind of scientific arrogance that surrounds the idea of life on exoplanets. And he said, we're fully aware now that we have to really open our minds up to all kinds of alternative forms of life. And I mentioned the Viking life science experiments back in the 70s, which were amazing for their time, but they were designed in the 60s, and it was really pretty much a matter of scooping up some sand, depending on which experiment you're talking about. But the basic idea was we'll inject a liquid in there and see if microbes respond to it by giving off gas with a radioactive signature. And it didn't work as far as we know. One may have, they still don't know for sure. They think it was just a chemical reaction with the soil. But it was really basic, and it was based on the idea of everything being like microbes on Earth. Now that we've seen so much more in terms of, there are critters that live under the surface of rocks in the Antarctic. There are creatures that live down by these black smoke or heat vents in the ocean, on the floor of the ocean, and thousands of degrees of heat. So there's a lot more awareness of all the alternatives. Life tries to find a way, right? If it gets started, it just goes bonkers and finds a way to survive. So that's what's going to be so exciting when you start seeing these gas signatures in the spectroscopy, and hopefully we'll see a biosignature somewhere.
The spectroscopy we saw today was due to a transit, which is fascinating. It's a planet going across the face of its star, and it's in that transit that you can see what the atmosphere of the planet is. And it's that was just fascinating. And of course,
and the fact that they can subtract that out from that intensity
amazing,
of light,
isn't it? It's amazing.
It's all about contrast and computation. And man, the computers at Goddard and other places must just be smoking at this point, evaluating all this data.
And of course, those two images of nebula, which are of course always the most beautiful astronomical images, just mind-boggling. Not necessarily scientifically, but just gorgeous to look at.
And that's important, and that's what was so wonderful about Hubble, and what's going to be wonderful about this. And of course, we've still got Hubble, so we've got these two instruments now working. The Nancy Grace Roman Wide Field Telescope, which is smaller than it's about the size of Hubble, so it's much smaller than Webb, but it's designed for looking at wide fields. It's not a high magnification instrument, but that'll be sending us other deep field infrared images. And, this is for NASA the gift that just keeps giving. If you want to touch people emotionally, if you want to talk to their hearts instead of just their minds, you bring out these incredible pictures of deep space objects, and it has been such good public relations for them, and especially with the international component, the fact that anybody in the world, with some limitations for trade law and so forth, but basically anybody in the world can submit something and at least get it considered. So that's it truly is a gift to everybody.
It's amazing. John, I don't know if you have all 5 of the images that we just saw. I put a link in the show notes, or rather in the chat, IRC chat, to the Flickr site where all 5 images live. I think it'd be fun to wrap this up with just a one-by-one look at all 5 of the images that we just saw in full screen. I don't know if you can do that, John. I know he's trying really hard.
I'm imagining the sound of an ectographic slide projector in the background of my uncle's living room. Flip, here comes the next one.
The big
fan. Here we are at the Grand Canyon.
What a slideshow, though. I'll tell you what, the most amazing views in the history of mankind. There are all 5 of them. Actually, there's 6 there because they're showing side by side the Hubble compared to, this is the most recent one they showed, this incredible star nursery where nebula where stars are being born, and those stars above the cloud are actually the newest stars. Quite amazing.
Carina Nebula.
Yeah, just unbelievable. This is the
Stephan's Quartet.
5 Quintet, really, because
Quintet,
there's a head that gets in the way, a galaxy that's interposed between us and the 4.
Right. It's like Mystery
really
Science Theater 3000.
Yeah, that's right. There's another image of that. I'm not sure how this differs from the first image. That's the same quartet, isn't it?
Yeah, I'm not sure if one of those is the Hubble image or if it's just different.
Maybe it's the Hubble. Yeah,
the same. Yeah, I think this is I think that's the Webb.
This is the Webb for sure, because you recognize those 1, 2, 3, 4, 5, 6.
Oh, they are Webb. Okay.
starbursts, but they're different instruments of the Webb. So yeah, really interesting.
Okay, one's the wide.
Really interesting.
Infrared.
And they're, oh, what a gorgeous view.
There's the Southern Ring Nebula.
And that's the image you want. That is wallpaper quality. That is amazing. And the same telescope, but two different instruments on the telescope, giving you different views. This is look at that. The binary star right in the middle. Yeah. Look at that. Wow. Wow. All of these images, the best quality is on Flickr. Look for NASA Webb Telescope. That's the Flickr account. WEBB, NASA Webb Telescope. And all of these images are available in the highest resolution that NASA is allowing us to download.
That's the image that you want to see in space and not growing on your arm, right?
Yes.
That'd be a bad afternoon.
I think you're right. I think you're right.
And here's the spectra from WASP 96b.
Unbelievable. Yeah.
That's some
really amazing images.
Water everywhere.
And there are full descriptions underneath each of these images so that you can see or know what you're seeing. The distance.
That one just blows my mind. Gravitational lensing is always an amazing thing, but to see it, that actively at work, and to know that
that's why those are
worms,
smears. Those little smears. That's as a result of the bending of the light coming from those galaxies
around the foreground object. So all those little smears are galaxies way, way, way further away than the foreground one. Which is just,
the combined mass of the galaxy cluster acts as a gravitational lens, bending light rays from more distant galaxies behind it. But also
the main mass, just a reminder
them.
Right, exactly. So the main mass, otherwise we wouldn't see them. The main mass is 4.6 billion light years. And then the ones in the background, the oldest ones in the background, are closer to 13. So that's how much magnification you can get from gravitational lensing.
Yeah.
Which, again, as you point out, you're looking back a couple of decades, this is just a theory. And then they started using it, and now it's routine.
Yeah.
And they just start targeting things because they know they can get gravitational lensing and this magnification.
Incredible.
It's a whole new way of doing business.
It's full of stars, and we are going to learn a lot more.
Said David Bowman.
Yes.
Very well said.
A lot more about them. I'm not quoting Sagan. I'm quoting Arthur C. Clarke, but it's much the same. Thank you, Rod Pyle, Editor-in-Chief at Astra. You probably have to go out and write a few articles now, and I wish you the best.
Some dispatches,
Really appreciate your being here. Of course, Rod does the fabulous This Week in Space show. Tarek is still in Singapore, but when he gets back, I'm sure you two will have a lot to talk about. I'm sure Tarek is watching in Singapore. Make sure you tune in for that. twit.tv/TWIS for This Week in Space. And of course, Rod joins me every Sunday on the Tech Guy Show. Not this Sunday, because I will be on the TWiT cruise, but a week from Sunday on the 24th, we can talk more about this.
A well-deserved vacation, my friend.
It ain't no vacation. I got 120 TWiT fans to entertain.
Well, that's true.
I'm just hoping the glaciers will be fascinating.
Oh, God, I hope so. That scenery ought to be sensational. We'll have to compare notes when I get back from my substantially less comfortable Arctic trek. We'll have to see what I saw versus what you saw. I'll be looking at rocks.
To hear all about that. Yeah,
you'll be looking at glaciers.
Great. When are you doing that?
We leave August 1st. We get back on the 26th, I think.
It's almost a whole month north of the Arctic Circle.
Yeah.
Arctic Circle. Thank you, Rod Pyle. Thank you to John Slanina, who got up early to come in and do this. We appreciate it, John. Thank you. I know John's as excited about this as we all are. Thanks to our chatters who joined us in the Discord and the IRC. Thank you for letting us indulge our space fantasies. That's it for this TWiT News special.
Leo,
I'm Leo
thank
Laporte.
you for getting up.
I'm going back to bed.
No, I know.
I do have.
Thanks for doing it. I appreciate it.
First, I'm gonna eat my breakfast, though.
Okay.
Thanks, everybody.
Enjoy it. Bye-bye.